All right, everybody, it is noon on June 21st. Thank you so much for joining us for this Antisyphon Anticast. If you were here for pre-show banter, thank you so much for joining us. We do it every single time we do a webcast / Anticast, whatever it is that we're doing. We always show up early because you show up early, and it's always good to see you. Make sure to join us in Discord, because in Discord, the whole community is there. You can share what you're learning. You can exchange gifts if you want to. Today we got Hal Pomeranz who's going to talk about Linux command line, new tricks for old dogs. And so we're going to turn it over to Hal. We'll be here to answer any questions in the back end if you have them. We'll also ask Hal questions at the end. Velda, go ahead.
No, I was just saying goodbye, everybody.
I
was doing my queen wave.
The wave. All right.
All right,
Okay.
if you're not Hal, go ahead and kill your cameras and microphones. And Hal, it's all yours. Have fun.
All right, thank you, brother. Hey, everybody, how's it going? It's been a while since I've done one of these. That seems like a shame. Memo to Velda, schedule more Hal webcasts until the audience starts complaining, and then schedule more. So, hey, you know me. I talk about Linux command line a lot. And so I was thinking about, I've been thinking about kind of the way I approach, Linux and Unix command line stuff, and I realized that I'm really old, So let me just sort of set the stage for you here, right? Like, so how old am I, right? So for me, like when I started with Unix, it was like the mid 1980s, and let me kind of describe the world of Unix in the mid 1980s, right? So my first Unix workstation that I ever worked on, the Sun workstation, was running BSD Unix on a Motorola 68020 processor. Okay, so Spark didn't exist. The System 5 Solaris, nope, not even a thing. This was real, sort of old school Unix. Around that time, the X Windows system had just released version 10. It was still being run out of MIT. Project Athena did most of the work on that. Xorg didn't exist. None of that stuff happened. This crazy guy named Richard Stallman had just incorporated this non-for-profit called the Free Software Foundation, and he was talking about basically creating a whole new operating system, but nobody really took him seriously. And we hadn't even gotten to BSD 4.4 yet. It was 4.3 was the new drug. System 5 Release 4 hadn't even come out yet. And everybody was learning Unix from the book you see on the screen, Unix Programming Environment, Kernahan and Pike. It's the AT&T Bell Labs press. This is a classic book, and still actually a really pretty good introduction to the Unix shell. But this was the Bible, right? This is how everybody was learning to Unix. That book was published, I think, in 1984 or 1985. And so that was the thing at the time. And so I learned a version of Unix that was in a lot of ways really primitive, compared to what we have now. And, one of the biggest differentiators was that the Free Software Foundation's new user space hadn't happened yet. It was still 10 years out at that point. And so I was learning a very classic, traditional Unix that was sort of an amalgam of BSD 4.3 and later Research System 5 when I graduated college and went to work at AT&T Bell Laboratories. That was my first gig, by the way, is doing Unix support at AT&T Bell Labs, Holmdel. And so, I learned this very kind of, traditional, straight-laced kind of Unix, and there was a lot less ways to get things done, right? There wasn't this multiplicity of things. And so I learned how to do certain things that became part of my wetware, if you will. It's like, how do you solve problems in Unix? And, like once you get comfortable with something, you don't really change, right? Unless there's some impetus in your environment to evolve, you just kind of keep doing what worked for you. And so over the years, as many of you are aware, I've done a bunch of different, command line blogs and Recently on Mastodon, I was doing daily Linux trivia questions and stuff like that. And what I realized, I just love Linux, but the other great part about that is that by doing that, I'm encouraging people to teach me new stuff, right? Like, so I'll throw up my old school, old dog approach for solving a problem and it works. And then, all the sharpshooters show up and say, wow, Hal, that's really cute. But have you looked at Linux in the last 10 years and know about, XYZ feature, which would make your life easier. And so, through a process of repetitive embarrassment, I've actually picked up some new tricks along the way. And so for those of you who are old dogs, or for those of you who are new dogs who are just starting to learn this stuff, I thought it would be fun to kind of put together a presentation about, kind of the way I would solve some problems, and then, the new way of exploiting some of these new features in these commands to get your freak on. So that's basically the idea behind this. And I've got, several hundred examples to go through with you in the next. No, I've just got, a few examples to share with you. Okay. All right. So here's the point where we abandon the slides and I go into full demo mode. The slides are in the channel for you to download later as a reference. But I thought that I would do, most of these as a live example because it's more meaningful. And so here, let's switch over into the terminal. That thing that Jason's afraid of. There we go. Hey, look at that. It's a terminal window. Okay, look, so no, I don't pray to demo gods, because failed demos are often more enlightening than working ones, right? Like my friend Jim always says, experience is what you get when you don't get what you want, right? And if the demo fails, we're going to get more experience that way. So okay, yeah, all right. You can tell from my screen, this is a Windows computer that I'm on. Let me address that issue. So for the longest time, I had a Linux laptop and an Apple MacBook Air as my daily driver, and I felt like I was getting away from Windows. I felt like I was losing my Windows knowledge. So I explicitly made my most recent laptop be a Windows machine to force myself to live in the Windows environment for a while, just to sort of get back on the beam there. So, because the warrior who knows only one way is vulnerable to attack. So it's always good to keep your hand in. And yes, it's Windows, but I've got, WSL2 and everything to make my life more sane. But yes, here we are. It's my Windows laptop on which I'm running a Linux VM, right? Which is running Debian 11. So don't hate me, just because I'm running my VM on Windows. Okay, so first example, right? Let's do an easy one. Okay, so I often find myself needing to sort lists of IP addresses. Okay, it's just, one of the things I'm often finding myself doing as an analyst. And there's always been this kind of classic sort idiom for sorting IP addresses. So this is, kind of the old school way here, right? So you would sort and you'd say, well, my, delimiter is a dot, right? That's how you break up the octets. And obviously we're going to do numeric sorting because it's IP addresses. But then you have to do this kind of painful thing where you say, oh, I want to sort first on the first octet, and then I want to sort on the second octet. Oops. And then I want to sort on the third octet. And then I want to sort on the fourth octet, right? And I think, yeah, so I have some IP addresses. Okay. And so that's always been kind of the classic formula. And let me just give you the first few sorted lines of that. Boom. Okay. So that is a ascending numeric sort, octet by octet. And the only problem is it's just like really a pain in the butt to type because you have to specify each individual octet to get the sorting function to work properly. And so, I rolled that out in one of my command line blogs, and very nicely, but several of my readers wrote in and said, by the way, did you know about this sort-v thing? So, one of the things that they slid into the GNU version of the sort command is -V for version sorting, right? So if you had, like, for example, kernel releases, 5.10.162, they wanted an easy way to sort those software version numbers. And so the -V sort will sort any number of, dot delimited numbers numerically. And so you don't need all this other stuff. You just say sort -V, and you get the same bang for a lot less typing, right? So sort -V, who knew? I didn't know. I mean, like, it took somebody to kind of, bonk me on the head and say, hey, how about this? Otherwise, I would have just kept doing it the way that worked, right? But that was more long-winded. So there you go. Just a simple thing to make your life a lot easier. So yeah, so version sorting also works for IP addresses really well. And I don't know, like, if you do any sort of network level analysis or anything, sorting IP addresses always seems to come up at some point in your life, right? Okay, so that's a quick and dirty one, right? Okay, sort-v. Let's move on to something a little bit different. I'm sort of going through the slides. I just want to make sure I do it in the same order as the slide deck for the people who are following along. Okay, so I'm going to talk about the find command for a little bit. Find is easily one of the weirdest Linux commands out there. It's also one of the most useful. And find, I mean, like, I could do this whole hour presentation on weird new things that have crept into the find command over the years, but let me just mention a few of them. So this is one that I used to use forensically all the time, right? So you're looking at a forensic image, and you want to find all the changes that have been made since a particular date and time, right? So, like, maybe you got an IDS alert that said, the attackers look like they broke into the machine around this date and time. And you want to find out everything that's happened on the machine since that date and time. Now, the problem with the classic find command is you'd have something like find-m time, right? Which you could specify a number of days. So you could say, show me everything that's been modified within the last 30 days, but that was the limit of your granularity. And if you're looking at, old forensic data and, something that happened in the distant past, it's hard to do M time in a situation like that. So, for example, if you take my Linux forensics class, we have an image where the attackers were active on the image in October of 2019. And so I want to find all the changes to the image that have happened since that particular date in October of 2019. Now, the way I learned to do this, in my sort of old school Unix universe is sort of a two-step process. The find command of my day didn't let you specify a particular timestamp. The command that lets you specify a timestamp would be something like the touch command. So I could touch a file and set whatever time I wanted. So let's say 2019, 10:04 at 0:00 in 0 minutes. Okay. So I'm going to make a file called temp my file, and I'm going to set the timestamp on that file, A time and M time, because that's what touch messes with. I'm going to set the time to that particular date and time. And then I can do find, mount hack dash newer temp my file, right? So I can't specify a date and time in find directly, but I could specify a timestamp on a file and then say, show me everything that's newer than that file whose timestamp I set. And you can actually set it up to seconds granularity if you want to with a touch command, although I didn't bother. Okay, so that was always the workaround for doing timestamps with the find command. So again, I'm showing this hack to people, and it's the typical person in the back of the room kind of sticks their hand up and says, "What about the newer MT option to find?" I'm like, "What? Excuse me? Say that again." So find, the GNU version of find now has a new option, -newer MT. And by the way, that's for last modified time, MT. But there's also newer AT and CT and so on, depending on which timestamp you want to compare against. But you can say find newer MT and then specify the date stamp in a variety of different formats. But the natural one would be something like 1004/00/0000, right? And that's a whole lot easier than messing around with the touch command and all of that stuff. And it's just a nice labor-saving feature that allows you to do what people have always wanted to do in find commands, which is specify date and timestamps. So yeah, so there's as I said, you can do that for any of the 4 normal timestamps just by changing that second to last letter in the option. Okay. So, I mean, again, these are convenience features, but it just makes your life a whole lot simpler to do it this way. So, other fine trickery that you might have missed out on, because there's a lot of stuff in find. It's easily one of the more complicated Linux commands out there. Okay, so one of the problems I set on my blog was, you have a directory, let's say user share, and you want to list all of the files anywhere under user share in sorted order by the file size. Okay, so in traditional find, you'd do something like this. You'd say, find under user share, right? Things that are regular files. And then you might, for example, exec word count -c to get the file size in bytes on each individual file. This is the reason I like this example, and I got people to do it, is because this is actually one of the few cases where you don't want to use xargs with find. You actually want to exec word count on each individual file rather than clustering them together with xargs. And then, okay, we want them in sorted order, so I'm going to do sort-nr, right? Actually, let's do, yeah, that's fine. Okay, and so off we go. I'm going to save us a little bit of output time and just pipe this whole mess into tail just so we see the last 20 lines or so, okay? So what's going on here, and what's taking so long, is the fact that every single file that find is locating, it's then execing wc-c on that file. So if there are thousands of files in the directory, it's actually executing wc-c thousands of times. And that, it just takes a while to do all of those executions. And then it's got to sort everything. But this is the way you would do it, back in the day, right? This is the Unix design religion. You plug together a bunch of these little basic building blocks like find and word count and sort and tail, and you turn it into some ad hoc query. And this was always the power of Unix, that you could use all of these little Lego bricks and do powerful things with them. Wow, this is taking a while. Maybe I shouldn't have done user share. It's actually a pretty big directory. Oh, come on. No. No. Maybe we should bring Jason back on and he can talk about honey for us while we're waiting for this to finish. Okay.
Are you good?
All right. You good?
I'm good. All right, never mind. You get the idea. So that was obviously taking too long, right? Cool. Let me show you something cool about newer versions of the find command. See, newer versions of the find command have, in addition to the old print option, have printf. And printf, along with it, has a number of different predefined escape sequences. So, for example, %s is the file size in bytes, right? Find already knows this because what find does is it walks through the directory structure and it's basically statting each object as it moves through the file system. So it just learns the file size kind of automatically as it's inspecting the inode for the metadata about each file. And so rather than having to call out to an external program, printf allows you to output some of those file details essentially for free while you're walking the file system. And you can do things like, oh, I want a tab, and then I want %p, which is the path name, the full file name, and then maybe a new line, right? So in addition to, specifying different criteria like file size or the file path, you can also insert literal characters like white space and dashes and things like that, however you want to format it. And this is much faster because it's getting the file size just from looking at the file. It doesn't have to call an external program like word count -c. And so this one will be done in no time at all. Boom, all done, right? I mean, it was effectively instantaneous because it was getting this data as it moved through the file system. So let's, instead of sort nr, let's do sort. And so the big stuff's at the bottom. Boom. Okay, so here are the largest files in under user sharing. Well, most of them are font files. That's interesting. And so there you go, right? So this is so much faster than the old school way of doing it because you're not executing an external command on every single file. You're just using the metadata from the file that find already knows to output what you want to output. So really, like if you haven't played around with this at all, bring up the manual page for find and look at the printf option and look at all of the different built-in escape sequences that are available. Let's find printf here. Here we go. So all the different timestamps you can output in a variety of different formats. So all of the normal sort of strict time stuff like that. File size in blocks, file size in bytes, which is what I was doing with %f. The file base name, so like you don't have to pipe things out to base name or just the directory name. So F is base name, the file name, H is the directory name without the file, and then P is the full file path with the name. crazy things that you'll never use, like the device number. I mean, I don't know that you'll ever use that. Permission bits. So all of the metadata, there is some percent sequence that you can use with printf to output the object. And it, like I said, it's so much easier than calling out to WC or stat or something like that on every file. And it's so much faster. So let me show you another example of find and printf to kind of bring this one home. So, sometimes when I'm doing a forensic investigation, I want to look through my evidence for files that have a particular extension, depending on what the case is. It might be JPEGs, it might be GIF files or whatever. So for example, let's do another find under user share. So find under user share, right? I want to find regular files and that are, I don't know, .lua files. Okay, so sure. So I want to look for files with the .lua extension. Okay, so that's, sort of the classic way of doing this. But what I really want is not the file names themselves. I want the names of the directories that contain those files. So I want to strip off the file names. Now, the old school way of doing this was that you would pipe this to xarg's dir name. So that would just strip down to the directory names, right? And then there's a lot of redundancy because there might be multiple Lua files in one directory. So you generally pipe that into sort-u to eliminate the redundant directory names and just have one copy of each directory. Okay. Here, let's see how long this one takes. Okay, so I'm using the benchmarking tool built into the shell to see how long this pipeline takes. Okay, so here are the names of all the directories under user share that contain Lua files. This one took about 0.34 seconds, 3.5, to do that. Okay. But you don't need to call out to dir name because you can use printf instead, right? So I can say, name star.lua, but instead of calling out to dir name, I can just do printf %h, which is the directory name without the file portion, and then a new line, right? So it saves you, having to do an extra pipeline. And interestingly, what I found interesting about this example is xargs is so efficient that it's effectively equivalent, at least on this limited input. If I did something that had more hits, like let's do JPEGs, right? No, it's still not a lot. What's the No, it's still about equivalent. So it's really interesting to me how efficient xargs is compared to just like getting it out of find. But in any event, this printf thing has endless, abilities to exploit for things that I used to use really complicated pipelines to do, and that is pretty cool to me. And I never would have known about it had one of my readers not bothered to show me up about this. So that's thank you for that. One more fine thing, and I promise I'll stop. So I was doing an example there, finding JPEG images, but let's suppose I'm looking for any kind of image files, JPEGs, GIFs, TIFF files, bitmaps, PNG files, whatever, and it's a Windows machine. So they might be upper or lowercase, and JPEG might be JPG, it might be JPEG is the file extension, whatever, right? And so again, the way I would do this in the old school way was I would do find, mount evidence, right? Type F, but there wasn't really a good way in find to do the pattern matching at the level I needed to do it. So I'd always end up calling out to egrep, right? So you do grep-e, I for case insensitive, and then you do a pattern, something like, what is it? JPEG, right? So that's either JPG or JPEG or GIF or BMP or PNG or TIFF, right? And, whatever file extensions you cared about, but you get the idea, right? So it needed to end with a dot, one of those things, right? So this would be the end of the file path. Okay, so you end up with a regular expression pattern that looks something like this. But again, you're calling out to an external grep program because find didn't have the capability to do regular expression matching. And then again, right, you might go off and pipe this into xargs dir name, pipe to sort-u to get a list of the directories where images were found in your evidence, right? Okay, and that's the classic Unix pipeline thing. You get a list of files, you filter them out using grep, then you pull off the directory names, and then you reduce the redundant directory names so that you get one canonical list. Cool, right? Okay, so here we can do that. Let's do that. Now I can do this in user share, right? And let's time this one too. I'm sort of curious how long this is going to take. Okay, so that it took about 4.4 seconds. So pretty straightforward. We get a lot of directories, obviously, because there's a lot of things with images in them. Actually, what I'm going to do, I'm going to send the regular output to dev null, just so that we can more easily see just how long it takes. Okay, so cool, right? And we did it this way because find didn't have the ability to do pattern matching. Well, it does now, right? So the GNU version of find now lets you do regex style matching. So find user share type F. And so there's iregex is the pattern matching operator. So this says a case insensitive regular expression match. Now, the thing about the iregex operator in find is it wants to match the entire file path. So I'm going to modify my regular expression to include a dot star to just eat up everything until the last extension, which is what I really want to match, right? So you have to modify your regular expression a little bit so that it matches the full file path, but otherwise it's pretty much the same. Okay, and now because I'm doing this in find, I can also use printf to only output the file path rather than pumping things out to dir name. And so from here, it's just sort-u. And again, I'm going to throw out the output. Now, there's a trick here. Find actually supports different regular expression types, right? The wonderful thing about standards is there's so many to choose from. So there's lots of different regular expression languages out there. There's, the traditional old school Unix regular expressions. There's what I'm doing, which is the egrep style or extended regular expressions, but there's also Perl compatible regular expressions and so on and so forth. And so you need to tell find which type of regular expression you want it to use, because otherwise it's going to default to the old traditional Unix style regular expressions, which are not as powerful. So what I want is regex type posit egrep, right, is what GNU calls it. So you actually need to tell it what kind of regular expression it's going to be hitting. But this looks okay. And it actually takes longer. So the regular expression library in find ain't as fast as the one that's built into GNU grep. And so maybe, you're actually better off doing it outside of find. I don't know, I mean, just from a performance perspective. But it just goes to show you, though, that there are things that you can do in find that we could never imagine doing back in the 1980s. And the fact that I can, combine regular expression matching with printf style output is pretty powerful in terms of, manipulating the data without a lot of complicated pipelining and things like that. So, no, I am not using WSL for this demo, although I could, because it's Ubuntu. No, this is actually a separate VM that I've got that's running inside of VMware. It's running Debian. Yes, it is being recorded, so don't worry about that. Okay, so enough about find, but you get the idea. Find has improved a lot since the olden days when I first started with Unix. And find was always very mysterious to me. It was one of the commands I mastered last because it was very complicated syntax, and admittedly the syntax has only become more complicated with all these different extensions to it, but it's pretty neat what you can do with modern find commands. Okay, so let's talk about another subject near and dear to my heart here, which is FIFOs. So what is a FIFO? A FIFO, or a named pipe, is basically an object in the file system. Looks like a file, but it works more like a pipe in terms of like command line piping, right? So you create a file with make FIFO, and you just specify a file name. I'm going to call it temp Hal's FIFO. Okay. Okay, so this is probably the only time you'll ever see a file with type P out here as the file type. It's a named pipe. Okay, so how does this work? So it functions like a pipe. So if you write data into the FIFO, you can have another process that's reading data out of the FIFO and doing whatever you need to do with it. Why is this useful? Okay, so this is useful because there are commands in Linux that only want to write to a file. Okay, they won't pipe to standard output. And one that I've been dealing with lately is the AVML tool, the Acquire Volatile Memory Linux tool from Microsoft, which is a good way of capturing Linux memory for forensic purposes. But the problem is that AVML insists on writing to a file in the file system. It has no direct ability to shunt the data over the network. Now, there are options to AVML that once you captured the memory dump locally, it will copy it via SSL, to an Azure Blob Store or, some URL that you specify. But it's still going to write the data into the file system, which, from a forensic perspective isn't great because you're consuming disk blocks and potentially overwriting evidence. So one of the things that I've taken to using a FIFO for is tricking AVML to make it think that it's writing to a file in the file system, when in fact, I'm going to use the FIFO to send the data over the network to some other machine that's collecting the data. So let me do this the low-tech way here. I'm going to set up a netcat listener on over in this window. Okay, so this would be the machine where I'm going to be receiving the network image. So I'm just going to tell it to listen on port 9999. we'll throw that into PV pipe view, which is another useful modern utility if you've never seen this before. PV is something that you can throw into the middle of a pipeline, and it gives you a little progress meter about the data that's flowing through the pipeline. It's really cool. And I'll show you how this looks once I start shoving data into this. And then I'm going to save this into, I don't know, images, my memory, capture line. Okay. Okay. So whatever ends up showing up on port 9999 on this machine is ultimately going to be saved into this file. Cool. All right. So we'll set that up here. Okay. And so what am I going to do on this end? Actually, I need to be root to grab memory. Okay, so I'm going to create a process to read from that FIFO, and we're going to pipe that into netcat to my collection machine. Oops. On port 9999. Okay, so this is the reading process. Whatever data comes into the FIFO is just going to get netcatted right up over the network to that netcat listener that I set up in the other window, right? Going to put that in the background in order to get my command prompt back. Okay, so that's just waiting for me to send data. And now I'm going to do AVML, and I'm going to send it to temp Hal's FIFO, right? Okay. Watch this. You know, wise man once said to me, when giving a live demo, never say anything more instructive than, watch this. Watch this. Ah. Da, 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 da. All right, hold on a minute. Let's start that again. Yep. Okay, all good to go. Hey. Hmm. Da, 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 da. Hmm. Right, that's good. Yep, it's the right IP. Hmm. FIFO. Temp test FIFO. Cats. Oh, help specify the port number. Okay. All right. Connections established. That's a good sign. And now. Boom. Okay. Huh. All right. It's happy now. So the memory dump is going into the FIFO. My cat command in the background is shunting it over the network to the listener in the other window. And you can see PV is telling you how it's going. So here's a little progress meter from PV. We've already transferred just under 4 gig of the memory dump, and you can see how it's going. PV is really nice for things like this, where you know how things are. You know, when you're doing an incident response, you're all hyped up and your adrenaline's going, and things just seem to take longer, right? Because your metabolism's jacked up. And so having this little progress meter telling you, oh, look, 8 gig done, it's just really, really soothing. Anyway, so that's PV, another little modern shell utility. You may have to install it as a third-party package, but you should be able to get it from your package repository, whatever it is. I just did apt install PV and boom, it was there. So this is a 16 gig memory image, so we're almost done here. And boom. Okay, there we go. There's 16 gig. And AVML's done on this side. If I was smart, I would have told the netcat listener to exit when it stopped receiving input. But okay, so I was able to take a memory image over the network without having to write a file to disk, because I fooled AVML into writing into my FIFO for me. Okay, so that's cool and all, right? But it turns out that you don't actually need the FIFO. The modern Linux shells have an output redirection that enables me to write to something that looks like a file. So basically, without creating the FIFO, because obviously, like, even creating the FIFO, modifies the machine that I'm working on. So it turns out that I don't have to go through all that rigmarole with the FIFO anymore. Let me go ahead and start up another listener. Okay. We'll just overwrite the memory capture we did. Okay, so actually, let me do this the right way. I'm going to add the -W1 option here. So that means wait for 1 second after the end of your input and then exit the netcat listener. Okay. Oh, oops. Oh. Never mind. Okay, cool. Waiting for input. So let me show you the trick here. So I can do AVML, and the trick is this syntax: greater than parentheses, right? So it's like output redirection, right? But it's output redirection not to a file, but to a process. Like $paren, blah blah blah. That's how you would like do command substitution. Well, this is how you can do output substitution. So redirect into netcat, and it's basically the exact same netcat command I did, just without the FIFO. That's it. And over here, you can see it counting up, right? So basically, this syntax fools a command like AVML that wants to write to a file. It says, yes, here's a file handle that you can write to, just like we did by creating a FIFO. But instead, that file handle is associated with a process, in this case, the process that's allowing us to write the memory image off the machine. Okay. So 16 gig of data, no muss, no fuss. So anytime you might want to use a FIFO, think about using this syntax instead. There are other things that I use FIFOs for. For example, you want to extract strings from a disk image, right? But it's Windows, so you want to extract both ASCII and Unicode strings. Now, I mean, you could, so for example, I could do strings -A on my, disk image, right? And that would get me the ASCII strings. And then I could run it again, and I could do strings -A-EL, which would get me the Windows 16-bit Unicode strings, right? Or I could do something like this. Cat disk image, type it into T. Now T writes one copy of its input to a file. And in the old days, I would do that into a FIFO, right? So temp my FIFO. And then it sends another copy to the standard output where I could, run strings-a here. And then, I'd have another process in the background that was catting temp my FIFO and piping that into strings-a-el to get the Unicode strings, right? So I'm basically using T to split the output into two different channels, right? And then I get the ASCII strings from one and the Unicode strings from another. Great, but again, we don't need FIFOs anymore. I can do this, cat disk image, pipe to T, right? And instead of writing to a file, I tell it to write to strings to a-el to get me the Unicode strings. And maybe I'll even gzip the output and then save it into a file like strings.unicode, right? And then the other end of this goes to strings -a. And again, maybe I gzip that output. And that goes into strings.ascii, right? .gz probably, since I'm gzipping it. Let's add the right file extension just so I don't confuse myself later. Okay. And so in a single command, just running through the disk image one time, I can generate both ASCII and Unicode strings at the same time, and I don't need a FIFO anymore for it. I can use this greater than parentheses syntax, right? So there's a whole lot of new output redirection and substitution stuff that's been happening in Bash and Z Shell and things like that while you haven't been looking. And so again, it's worth sitting down and looking into this stuff. Other things that have been happening while you might not have been looking. The Bash shell has gotten the ability to have true string indexed associative arrays. So it's got real data structures and things like that. There's all kinds of wacky shenanigans that you can do in these modern shells that you might not have been aware of. Right? Anyway, so go and maybe take a look at some of the more recent shell examples that I've been working on. Let me I'm going to now jump to the end of the presentation. So all the stuff that I showed you is documented in the presentation slides, right? Or you can go back and you can watch the recordings. So this is my contact information if you have questions after we leave here. If you go to my InfoSec Exchange Mastodon profile, there's a link to the questions and answers for the daily command line trivia challenge that I was running on Mastodon for a while before my life got derailed by various stuff. So if you go there, you can find a link to a whole bunch of command line examples. There's also the old command line Kung Fu blog that I used to do with Tim Medine and Ed Scotus. As I mentioned at the beginning, during the pre-show banter, I'm going to be teaching a 2-day Linux command line skills class at Wild West Hackenfest. You can sign up either in person or virtual, and I hope to see you there. If you want to know what that class entails, all of my courseware is Creative Commons licensed. And if you want to download my class, you can do it at the GitHub link that you see on this slide. So just go to GitHub, Hal Pomeranz, and look for my Linux command line class. It has the PDF of the slides for the course, as well as all the lab exercises, which you can download and do on a Linux machine of your choice. But I'd love to see you either in person or virtual at Wild West Hackenfest for the pre-con training for 2 days of Linux command line shenanigans. And any other questions? I'm going to quickly look at the Discord.
Hey, Hal.
Hey,
Well done.
Well done.
thanks.
Quite fast.
Yeah, that was fast.
Time
and
flies when you're having fun.
yeah, when I say that's fast, like imagine 15 more hours of that with Hal.
Exactly. Imagine 15 more hours.
Really selling it, Hal.
No, it's a lot of fun. We start with I start assuming you know nothing, and by the end of 2 days you're actually doing some really meaningful things with the command line.
Yep. So if you look inside the Zoom chat, you can see a link to the Wild West Hackenfest pre-conference training. If you want to take that with Hal. Also, you get to come to Deadwood. Is it virtual too, Hal, or is it just in person?
No, it's both. We're doing both. I'm going to be there in person. So if you want to spend 2 days locked up in a room with me, I'll be there. But if you can't make it to Deadwood, we're also doing it virtual. So
yep. And Hal, there's a question in Coyote asked, as a person brought up, have you ever tried the -u with the find command as a substitute for piping to sort of for unique?
No, that's a new one on me. I mean, like, so I'm well used to using sort-u to avoid the sort pipe to unique paradigm, but I didn't realize that there was a unifier in find as well. Well, let's see. That's why I do these things, because like I pick up little tidbits like that.
I like that you said -u instead of -u.
Dash u minus the old -u.
Hack u minus u dash u. It's okay. I understand all of them.
I know.
Wayne says, thanks. As an old dog of about the same vintage as you, I appreciate the updates and shell capabilities.
Yeah. Yeah, it's always like, oh, you can do that now, huh? Yeah, that's cool.
Someone said, as someone who's been using the command line for so long, have you picked up any tricks to learn it faster?
Oh no, I mean, the way you learn it is by forcing yourself to do it, right? If you really want to learn Linux, make your daily driver laptop be a Linux machine, and just live through the pain of it. The joke is, every welder has 10,000 miles of bad bead in them, right? Every Linux enthusiast has 1,000 hours of pain and suffering while they're learning the operating system. But it does get better, and after a while you start doing this stuff just kind of naturally, and then after a while you start dreaming in it, and that's when it becomes really scary. So
yeah, I took a class a long time ago, and the person who was running the class only used the keyboard. They never used the mouse. They had mapped everything to the keyboard. Right. And after that, I was like, all right, no mouse until I figured this out. And it was excruciatingly painful for a while. So it's almost like the same thing here. Like you just go command line, right?
Yeah. And in fact, like when I'm doing a class like this, I actually have to like stop myself from doing some stuff that programmed into my wetware, ages ago. So, you'll see me doing things like, make FIFO, temp, this FIFO, and then I'll do things like cat, bang dollar, pipe to netcat, blah, 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 blah. Well, what the heck is this bang dollar thing? Well, bang dollar is the old way that we used to do history substitution, right? So this means the last argument of the previous command, right? And I learned that because back in the day, we didn't have the history editing that you have in modern shells, right? And so it was, you got used to doing these keyboard shortcuts for history editing because that's all there was. And I actually stopped myself from doing that in a lot of my beginner classes because I don't want to confuse people with that old historical stuff that just I learned back in the day, but that isn't really as important as getting some other concepts into your brain, right? So
a lot of thank you, a lot of
Stop
that.
me,
And there was a question about the recording. It'll be posted on our YouTube channel in a few weeks
Mhm.
for people.
Yeah, it's first of all, we produce a lot of content, so it takes a while to edit. Second of all, we love when you show up live because it becomes more of an interactive opportunity for us. And then later on, you can go ahead and watch the recording. But if you like to just watch recordings, then most likely you're not here.
yeah, exactly. Yeah, and there's speaking of the YouTube channel, I've done several of these different command line presentations over the last couple of years with Antisyphon. So there's already some other command line kung fu recordings out there on the channel. So if you're jonesing, waiting for this one to show up, you can go back and watch some of the older.
That's a really good point. And then lastly, Hal, final thoughts before you wrap up today. What are your final thoughts?
What are my final thoughts? I'm looking forward to seeing everybody at Wild West Hackin' Fest again. Always a good time. I think the best piece of advice, career advice I ever got was learn one big new thing every year. It doesn't matter what it is. Could be Linux command line, could be, reverse engineering Windows executables. It could be, learning how to be a better parent. It doesn't matter. Always learn something, be learning something. That's how you have a long career. That's how you stay interested. And that's how you avoid burning out, at least in my experience. So, if you decided that learning the Linux command line is what you want to learn this year, then I'm happy to help you out with that. But learn something. And, by the time you get in 30 odd years into your career like me, you've learned a lot of stuff.
Hal, thank you so much for sharing your knowledge today with the Antisyphon community. Thank you for tuning in for this Anti-Cast. Hopefully you'll tune in for more. We got it scheduled out every Wednesday for the foreseeable future. So we'll see you here next time. And thank you so much for joining us today. I think that's it.
I think Ryan
All right.
needs to
All right.
Yep. Kill with fire, Ryan.
kill it.
Kill the fire.
Ryan.
Nuke it from orbit. It's the only way to be sure.
It's not murder.